In iMars, a fully automated multi-resolution DTM processing chain called Casp-Go has been developed. It is based on the open-source NASA Ames Stereo Pipeline and the fifth generation of an adaptivity score correlation-based subpixel matcher. The original Ames Stereo Pipeline developed at the NASA Ames Research Center is a suite of automated geodesy and stereophotogrammetry tools designed for processing planetary image capture from the orbital and landed robotic rovers. The figure on the left shows a systematic flow diagram of the key processes involved. ASP takes ISIS formatted left and right image as input and starts stereo processing by firstly pre-processing, which includes map projection, image normalization, and filtering. And then disparity mapping initialization uses a pyramid-tiled integer-based correlation approach to find correspondences between the pixels in the left image and pixels in the right. And then subpixel refinement to obtain subpixel correlation from their integer estimates. And fourthly, triangulation that uses a geometric camera model stored in ISIS cube file to find the closest point of intersection of the two camera rays from the disparity map. And finally, DTM generation and image auto-rectification. The Casp-Go pipeline is shown in the figure on the left. Apart from the ASP processing, 5 additional workflows were introduced to further improve the ASP results. This includes a fast maximum likelihood subpixel refinement method to build a float initial disparity map, an outlier rejection and erosion scheme to define and eliminate some mismatches, a adaptivity score correlation and region growing-based refinement and densification method to refine the disparity value and match the unmatched and mismatched areas, calculating grid point interpolation to generate DTM as well as a height uncertainty for each DTM point, and array co-registration with respect to HRSC image. The original ASP pipeline was investigated in early stages of the iMars project. High-res stereo images of the three most observed sets on MOLA and MSR were chosen. The reference DTMs and images were taken from the HRSC products overlapping with the CTX images. Generally speaking, different DTM pipelines have different kinds of artifacts. For example, the ASP processing chain has a quilting artifact caused by the initial integer-based correlation, and field matching area for textureless places. These artifacts are generally minor for GIS and visualization after setting the DTM spacing to a ratio of 3:1. However, for detailed geological study of selected sites, a DTM with a higher level of quality and lower level artifact is always more desirable. Therefore, based on the open-source ASP pipeline, we further added several key components to specifically address issues found from the experimental products in order to develop a more optimal processing chain. Casp-Go has improved the performance compared to the original ASP system in terms of co-registered aerospatial coordinates with respect to HRSC and MOLA. The bottom left image shows an example of the mutual shaped adaptive scale invariant feature transform type points that we used in this processing chain from the MERB CTX array on the left and HRC array on the right, showing increasing uncertainty values from blue to red. Improved the DTM completeness for unmatched areas. The figure on the right shows an example of the improved completeness using Gotcha refinement for difficult areas of the MSR CTX DTM. Reduce the DTM artifacts from the maximum likelihood initial disparity refinement method and the strong outlier rejection scheme. Improve the DTM accuracy from ARC refinement on the subpixel matching result. Uncertainty values for every grid point in interpolated areas. The Casp-Go processing chain has been tested to 6-meter Emerald CTX image over the MER and MSR and a large area mosaic over the USGS MC11 East and West area, about 100 stereo pair, and then applied to the production of planet-wide DTMs and arrays from 4,500 CTX and about 400 high-res images. More DTM projects that have been processed in the iMars product can be found on the iMars homepage.